Well, in previous videos, we've done several examples of solving systems of linear equations, particularly three equations, using matrices and the method called Gaussian elimination. Our goal was to start off with a matrix and then do the three-row operations until we get one in this form. Well, now we're going to learn a second way to do it called the Gauss-Jordan Elimination method, where instead of looking like this, where above the ones, these could be any numbers you want, these asterisks, we now want it to be just like this. We want to have ones down this column, and not only zeros below, like over here, but we want to have zeros above as well. So that's going to take just a little bit more effort using the matrices, but you'll find once we are done to this level, we no longer have to do back substitution. We immediately know the answer, the solution. Okay, so the recipe is basically identical to Gaussian elimination, except for the fact that when we get this one here in the top left corner and we get zeros below, and then we come down the diagonal and we turn this element into a 1 using the row operations. Now we have to get zeros below and above. And then finally, in a system of three equations where you have three rows, you get down to the third one. And once you're done here, well, before we were basically done. We didn't have to get zeros below because we're on the bottom row, but we didn't have to get zeros above either. Now we have to get zeros above. So the matrices are a little bit more effort, but then you don't have to do any back substitution, as we'll see. Okay, so we're going to use the Gauss-Jordan elimination method to solve this system of equations. So I don't know how many matrices I'm going to need, so I am going to start way over here to the left. And first we write out the augmented matrix associated with this system of equations. So it's going to be 3, -2, 8, 9 for the first row. 3, -2, 9, -2, 8, 9. And the second row is -2, 2, 1, 3. -2, 2, 1, 3. And then a 1, 2, -3, 8. Okay, so this is the augmented matrix. Let me make sure that's a -2. This is the augmented matrix. It corresponds to this system of equations. So now we are going to do, starts off just like the Gaussian elimination. We need to turn this 3 into a 1. And I can see a couple of different ways to do that. Can you as well? Actually, more than 2. Let's go over some of the possibilities and we'll choose which one we think is the easiest. The most obvious, well, maybe not the most obvious, but one that almost always works, is you just divide the whole row by 3, and then you'd get a 1 here. But if you do that, you're going to get -2/3 and 8/3, and you're going to have fractions to deal with, which is perfectly fine. It might slow you down a little bit. Another option would be to, notice we have a -2 here. I could add row 2 into row 1, and that would give me a 3 plus -2, and that would give me a 1. And probably the most simple, without having to do any arithmetic, is just switch row 1 with row 3, because we have a 1 right here. So I'm going to do that. Let's go row 1, double arrow, row 3. Switch row 1 and row 3. Okay, so row 2 stays the same. Maybe I'll write that one first. So all I'm going to do is take row 1 and write it up here, row 3 and write it up here as row 1. 1, 2, -3, 8. And then row 1 is going to become row 3, so 3, -2, 8, 9. All right, we've done step number 1, baby step number 1. So now I'm going to use this 1 to zero out below it. So I'm going to have to add a 2 into this one, which remember, you're not allowed to add a number to a row, but I can add 2 times row 1 into this. And if I had 2 times row 1, that's going to give me a 2 right here. I'm not going to change row 1. I could write 2 times row 1 up here if I wanted to. And then I'm going to add that into row 2 to give me a 0. And then I'll subtract 3 times row 1 from row 3 to turn this 3 into a 0. I'm going to do all of that at once. So I'm going to do row 2 plus 2 row 1 and row 3 minus 3 row 1. So you'll notice, I may not have mentioned this already, but see the coefficients that you're multiplying, or the number you're multiplying by row 1, the 2 and the negative 3? Well, it's always the opposite of what you're turning into a 0. This is a minus 2. There's a plus 2. Here's a 3. Here's a minus 3. Okay, so row 1 does not change at all. Row 2 plus 2 row 1. Well, maybe just for the fun of it, I'll go up here to the scratch paper and write 2 times row 1. Well, 2 times row 1, you just have to double every number in this row. So it will become 2, 4, negative 6, 16. So now I just add that into row 2. So 2 and negative 2 give me 0. That was our goal. 2 and 4 give me 6. 1 and negative 6 give me negative 5. 3 and 16 give me 19. All right, so maybe below that I'll write 3 times row 1. I'm not going to do this all the time, but since we're just starting, 3 row 1 would be 3. 3 times 2 is 6. 3 times negative 3 is 9. 3 times 8 is 24. So I'm going to add 3 row 1s. Sorry, I'm going to subtract. So I'm going to take row 3 and subtract 3 row 1, which is this. So I need to subtract. Actually, maybe I'll do this, and then we can add. I'll do negative 3 row 1, and that would be a negative 3, a negative 6, a positive 9, and a negative 24. And now I'll say I'm adding it. I'm going to add this to row number 3. 3 and negative 3 gives me 0. Negative 2 and negative 6 gives me negative 8. 8 and 9 gives me 17. 9 and negative 24 would be, is that negative 15? 15 and 9 is 24, yeah. Okay, so, well, great. We got our original one, our first one, and we got all zeros below it. Now what do I need to do? What's the next step? I need to turn this entry right here into a 1. So we have basically, a couple of possibilities. One is just divide this whole row by 6. And that'll give us fractions, but sometimes you got to do that. Another one would be taking some multiple of this row and adding it into this, but that would even be uglier. And switching rows wouldn't help because how do you turn this negative 8 into a 1? You have to divide this whole row by 8, and then you get fractions there anyways. So I think I'm kind of stuck with dividing this row by 6. So I'm going to say 1/6 of row 2. And again, if you wanted to, you could write that like row 2 over 6. We're dividing the whole row by 6. Okay, so I'm going to write it down here. First row, no change. Third row, no change. And then I'm just going to divide all these elements by 6. So it'll introduce a few fractions, but that's okay. 0 divided by 6 is 0. 6 divided by 6 is 1. Negative 5 over 6. And 19 over 6. All right, so great. We got a 1. Now we're going to use this 1 I'm drawing the box around to get a 0 above and below. So I'm going to have to do 2 operations. And row 1 is going to change, so I put row 1. And I need to say minus 2 of row 2. Minus 2 times row 2. And row 3 will be plus 8 row 2. Once again, the coefficient here, we're changing row 1, and we need to change this 2 into a 0. So we're taking row 1 minus 2 instead of plus 2 to give us a 0. Minus 2 times row 2. And this is row 3 plus 8 row 2. So in this case, the only row that doesn't change is row 2. Okay, now let's do row 1 minus 2 row 2. All right, this could get a little complicated, but let's go with it. Row 1 minus 2 row 2. I'm going to write on my scratch paper 2 row 2 right over here. Okay, way up here. I need to know, I'm going to do minus 2 row 2, so then I can add it into row 1. What is negative 2 times this row 2? It would be a 0, negative 2, and then what do you get if you multiply negative 5 over 6 times negative 2? Negative times negative is positive, so it's going to be 5 times 2, 10 over 6, which is 5 times 3, 5 over 3. Positive 5 over 3. 19 over 6 multiplied by negative 2 would be negative 19 over 6, negative 19 over 3. When you double something, you're multiplying it by 2 over 1, and the 2 can cancel with the denominator of 6. So it gives me 19 over 3. And this is negative because we're multiplying by negative 2. So all I need to do for row 1 is add row 1 to this, negative 2 row 2. And that's going to give me a 1 and a 0. That was what we needed, that 0 right there. And then what's negative 3 and 5/3? Well, that's negative 9/3. I'm running out of places to write things, so negative 3 is negative 9/3 plus 5/3. So that would give us a negative 4/3, right? Okay, and then we have to add 8 to negative 19/3. Well, 8, if you want it to be written in thirds, you'd have to multiply it by 3, and you'd get 24/3. So 24/3 minus 19/3. And that would give us 5/3. 5/3. And now row 3. I need row 3 plus plus 8 times row 2. So let me write down, I'm running out of room here, but I'm going to write 8 row 2 would give us 0, 8, 0 times 8, 1 times 8, and then you multiply the negative 5, the numerator times 8 for negative 40 over 6, which is negative 20 over 3. Negative 20 over 3. And then I multiply 19 over 6 by 8. Well, 19 over 6 times 8 over 1 means the 8 and the 6 could cancel to be a 4 and a 3. And then 19 times 4 is 19, 38, 76. 76 over 3. So that goes right here, 76 over 3. So this is 8 times row 2. And I need to add that into row 3. So 0 plus 0 is 0. Negative 8 and 8 is 0. That's what we had to get. 17 minus 20/3. 17 is 51 over 3 because 3 times 17 gives you 51. That's 17 minus 20 over 3. That looks like, what, 31 over 3. All right, almost done with this row. Then we've got negative 15 plus 76 over 3. Negative 15 plus 76 over 3. Let's see what that gives us. Negative 15 would be what? Negative 15 is negative 45 over 3. That is negative 15, written with 3 as a denominator, plus 76 over 3. So what is that? What is 76 minus 45? 31. Positive 31. Oh, look at that. So happy. So happy this worked out nicely here. So let's review what we've done. We got a 1 here and we got zeros below. Then we went down the diagonal, we turned this number into a 1, and we got zeros above and below. And now we have to go where? Down the diagonal and turn this one into a 1. And guess what it is? It's going to be a 1 very simply. All we need to do is what? Maybe I won't skip it this time. I'm going to go ahead and write it out. All we need to do is, how do you turn 31 over 3 into a 1? What do you multiply by? The reciprocal. So we're going to do 3 over 31 row 3. And that will give us a 0, 0, 1, 1. So let me write the first row, 1, 0, negative 4/3, 5/3. Row 2 is 0, 1, negative 5/6, 19/6. And this is going to become 0, 0, 1, 1. Make that clear here. 0, 0, 1, 1. So, if you just ran out of time on a test and you wanted to write down something for the answer, what do we know right now? By row 3, we know that z is a 1. Because 0 times x plus 0 times y plus 1 times z, or z, is equal to 1. So we have one more matrix to do. We need to just get zeros above this 1 that we just created. All right, so how am I going to do that? Let me write down the row operations. It'll be 2 row operations. Row 1 is going to change, and row 2 is going to change. Row 3 we're done with. Row 1, I have to add something. It's going to be add 4/3 times row 3 plus 4 over 3 row 3. And this one we have to add 5/6 of row 3 plus 5 over 6 row 3. And this actually will be pretty easy to compute because, for example, 4/3 of row 3 is just 0, 0, 4/3, 4/3. 5/6 of row 3 is just 0, 0, 5/6, 5/6. So since this is the last matrix, I won't go all the way to the left. Maybe I'll just go right to here. Row 3 doesn't change. Okay, so now let's go to row 2. Let's go up one at a time. Row 2, I have to add 5/6. So 0, 0, 5/6, 5/6. I need to add that into here. So I'm going to add 0 to the first two, 0, 1, and then adding 5/6 to negative 5/6. And what do I get if I add 5/6 to 19/6? 24/6. What is 24 over 6? 4. All right, one more row. This time we're going to add row 1. We're going to take row 1 plus 4/3 of row 3, which means we're going to add a 0 and a 0, which doesn't change the first two elements, and then we're going to add 4/3, 4/3. So 4/3 to negative 4/3 gives us 0. That was the reason we took that row operation. And then what's 5/3 plus 4/3? 9/3, which is 3. Okay, that was fairly painful, but look, we know the answer now. Z is 1, Y is 4, X is 3. Remember, this is the X column, the Y column, and the Z column. So this is 1 times X, or just X, plus 0 plus 0. X is 3. 0, Y is 4, and Z is 1. So the solution I will write like 3, 4, 1. Make sure you get it in the correct order. The top one being X, and then Y and Z in that order. Okay, well, we got one more video for this section. We'll do one more example, and we'll be done with the Gauss-Jordan elimination method.